Hey, it's Mr. E here, and our aim for this video is how do we solve radical equations. So here's a nice little quick warm-up for you. How would you solve these? Okay, so the one on the left says x squared equals 4. The opposite of squaring is square rooting, so we would square root both sides. And we get x equals 2. And by the way, also x can equal -2. Because -2 times -2 is also 4. For the one on the right here, to solve this, we would square both sides, because the opposite of square rooting is squaring. So we would square both sides. So when we square the radical, we lose it, and we get x equals 16. So x equals 16 for the one on the right. Okay, so a radical equation is an equation where the variable is under the radical. So here are some examples of radical equations. Here are some steps that you can consider when solving radical equations. Pause the video and copy these steps down to your notes. Okay, so here's our first example. Solve for the values of x that satisfy the equation. So our first step is to make sure that the radical is isolated. What that means is that the radical should be by itself on one side of the equation. And we already have that here. So we can just go ahead and focus on step 2, which is to square both sides, because the opposite of square rooting is squaring. So we square both sides. So when you square the radical, you lose the radical. So you're just going to get x minus 1 on the left side, and on the right side you get 4. So the first step was, for this problem, was to square both sides. Okay, now you're just going to solve it. It's a regular equation. So add 1 to both sides. The 1s are going to cancel out here, and we get x equals 5. All right, now look, it's very, very important. Listen to my voice. This is super important. You must check. You must. It is a requirement. You must check your answers, because sometimes with radical equations, you don't have a solution. So you have to check. So let's go ahead and check it. So you're going to check with the original. So check with original equation. That's just shorthand for with. So with original. So we're going to plug into the original. So that would be radical 5 minus 1 equals 2. 5 minus 1 is 4. Radical 4 is 2. So it does check out. So the answer checks. Therefore, our answer is 5. Example 2. Solve for all values of x that satisfy the equation. Okay, so we got to isolate the radical, because as you can see here, the radical is not by itself on one side of the equation. So we have to isolate it. We got to get it by itself. So to do that, we're going to subtract 5 from both sides. So these 5s are going to cancel out. And we're going to be left with radical 2x minus 1 on the left side, and on the right side we get -3. Okay, next we're going to square both sides to get rid of the radical. So we're going to square the left side, and we're going to square the right side. Square the radical, you lose the radical. So you get 2x minus 1 on the left side. Negative 3 squared is positive 9. I'm going to say that again because you guys confuse that sometimes. Negative 3 squared is positive 9 because it's negative 3 times negative 3. Negative times a negative is a positive. So now we're going to continue solving. Add 1 to both sides. The 1's cancel out. We get 2x equals 10. Divide both sides by 2. 2's cancel out. You get x equals 5. Okay, now we have to check our solution. So let me make some space over here. Let me just, give me 1 second. All right, so we're going to plug into the original equation. So check with the original. So that's going to be this, radical 2 times 5 minus 1. And then plus 5 outside the radical equals 2. Whoops, let's get rid of that. Sorry about that. Ignore that. 2 times 5 is 10. So we got 10 minus 1 under the radical. And then plus 5 equals 2. 10 minus 1 is 9, so we got 9 under the radical, 9 under the radical now. So you got radical 9 plus 5 equals 2. Radical 9 is 3, so we got 3 plus 5 equals 2. 3 plus 5 is 8. 8 does not equal 2. So the answer does not check. Therefore, there is no solution. There is no solution. So we have an empty set. This is what we call an empty set for the solution. So there is no solution for example 2. See, that's why I told you it's important to check, because sometimes there is no solution. Okay, one more. Example 3. Solve for all the values of x that satisfy the equation. So you want to isolate the radical. So we're going to subtract 1 on both sides. The 1's cancel out here. So we get x minus 1 on the left equals radical 5x minus 9. Now you got to get rid of the radical, so that means you're going to square both sides. So see what I did there? I just put that whole side in parentheses because I have to square that whole thing. And you're going to square the right side as well. All right, now x minus 1 squared is, I'm going to do this over here. X minus 1 squared is x minus 1 times x minus 1. So you have to actually FOIL this out. And when you FOIL it out, you basically get x squared minus 1x minus 1x plus 1. When you combine the two middle terms, you get x squared minus 2x plus 1. And then on the right side, you just lost the radical because you squared it. So you get 5x minus 9 on the right side. As you can see, this is a quadratic equation, so we have to set it equal to 0. We have to follow the steps for solving a quadratic. So we're going to move the 5x to the other side, and we're going to move the negative 9 to the other side by using inverse operations. So everything on the right side here is going to cancel out. And on the left side, we get x squared minus 7x plus 10 equals 0. Okay, now you got a factor. So you got your double bubble there, your two sets of parentheses. So you need two numbers that multiply to positive 10 and combine to give you negative 7. So we know it could be 5 and 2, and we're going to say that these both have to be negative. Negative 5 times negative 2 is positive 10. Negative 5 minus 2 is negative 7. Split them. Treat them like separate linear equations. So you have x minus 5 equals 0, x minus 2 equals 0, plus 5, x equals 5, plus 2, x equals 2. And we're done, right? No, we're not done, because you must check it. So let's do that real quick and then we'll finish up. Let me just erase this stuff here to give us some room for the check. Get rid of that. Get rid of that. Get rid of that. All right, so let's check this thing out. All right, so first let's check x equals, whoops again. Let's check x equals 5 first. We gotta check both of them. So if we plug in 5, we're gonna get this, right? We're plugging into the original. Then that works out to this, that works out to this, that works out to this, that works out to this. So the 5 checks out. So the 5 definitely checks out. So that is a solution. X could equal 5. Let's check x equals 2. So you're going to plug it into the original. And we're going to get 2 equals radical 10 minus 9 plus 1. And that's going to be 2 equals radical 1 plus 1. And that's going to be 2 equals 1 plus 1. And that's going to be 2 equals 2. So the 2 checks out as well. So they both check out. So here is our solution set. Since they both check out, you don't have to reject any of the x values that you found, because they both check out. But had one of them not checked out, you would have had to reject that value for x. All right. Thanks for watching this video. Have a great day. Take care. Sorry for the length. Peace.